Hi students, welcome. In this video we will understand the problem based on principle of superposition. So students, for that here see the problem is a brass bar having cross-sectional area of 500 mm square is subjected to axial forces as shown in figure. Find the total elongation of the bar. Take E, that is Young's modulus, is equal to 80 GPa. Okay, so this is the figure here, and as we know here 80 GPa means here 80 kilonewton per mm square. Okay, so now to solve this problem we will simplify this diagram. Okay, so this is the problem based on principle of superposition, means here we will simplify this arrangement, that is this is the single bar. Okay, and it has different forces acting on it, as you can see here. Okay, so now let first take one by one. First we will take the AB bar, then we will take the AC bar, then we will take the CD bar. Let's see how it is. And here this is the principle of superposition, means we will simplify this diagram and we will calculate the elongation for each section, and from that we will find out the total elongation, that is algebraic sum of all these elongations will be our total elongation of the bar, and this is called as principle of superposition. So now see here, for that here let's first take this bar, AB bar. Okay, this is our AB bar. Okay, A, and this is B. Okay, now we will now this force, that is 100 kilonewton force, we will divide this into 80 kilonewton, and another E will be here, we will consider as 20 kilonewton. Okay, so we will first take this 80 kilonewton, and force is tensile force, as you can see here, arrow is outwards. So here this is our 80 kilonewton, and this is also at B, this force is 80 kilonewton. So here also it is 80 kilonewton. Okay, now we will take the bar AC. So for that here take, this is our bar AC. Okay, so now here we will remain with, at A point we will remain with 20 kilonewton. Okay, force. So here 20 kilonewton, here it will be the 20 kilonewton. 80 plus 20 is 100. So at A point 100 kilonewton we have completed. Okay, force. So now at the opposite end also there is a tensile force, as you can see here. We will divide this force 50 kilonewton into 20 kilonewton, and another will be 30 kilonewton. Okay, so now here also this is tensile force, which is of 20 kilonewton. Okay, now we will take the bar CD, as you can see here. So for that here C and D. Okay, this is C and this is D. Okay, and as you can see here, this force is acting inside of this bar, that is compression is happening here. So in this case the force direction is at this direction. So here this is the direction of the force, and it will have the same force at C, that is sorry, here it will be the now 30 kilonewton force we apply. 30 will be the remaining force, 30 kilonewton. As you can see here, 30 plus 20 is equal to 50. So at C point there will be we have divided this 50 kilonewton into 20 kilonewton and 30 kilonewton in the same direction, as you can see here, in the rightward direction. So and here also there is at D point there is a 30 kilonewton force is acting. So here it is a 30 kilonewton. As you can see here now, this is 80. we have simplified this force distribution on this bar. Okay, so we have simplified this force distribution. So here, as you can see here, this is the length is 500 mm it has, and it has 500 plus 1000, so it is 1500 mm length. L. So this is L1, this is L2, and L3 we have here now 1200 mm, 1200 mm. Okay, so we have simplified this brass bar into sections, and we divided the forces acting on each bar equally. As you can see here, this 100 we have divided into 80 plus 20, 100, 80 and 20, as you can see here, and here also this is the 80 kilonewton, and this also again we have simplified, that is divided into 20 plus 20 and 30. As you can see here, 20 is here acting. As you can see here, both the tensions are equal, both the tensions forces are equal, both the compression forces are equal. As per that, we need to simplify this diagram. Okay, from that now we will take the each section to calculate the total elongation, that is here total is, let's take the take here delta L, that is change in length is equal to, now as we know here, common here formula is P L upon AE. This is our general equation. So now this general equation will be simplified as here delta L is equal to here P1 L1. Okay, P1 L1 is, this is for this one, this is our P1, this is P2, and here this is P3. Okay, now as you can see here, this is the tensile force, so here it will be the plus, so here it is a plus. Now we have P2 L2 here, also as you can see it is a tensile force, so here we have plus sign, so here it is P2 L2, and here as you can see here, this is the compression force, so here for compression it will be the minus, so P3 L3. Okay, and divided by AE, area is same as you can see here, and this is brass bar, and for brass bar the Young's modulus is same, so here AE is the common, as you can see here. So now we will put the values in this equation. So here see, P1 is here we have 80 kilonewton, 80 kilonewton into L1 is our 500 mm, so 500 plus here we have 20 kilonewton force, 20 into we have 1500 mm length, 1500 mm length, minus for compression we have here 30 kilonewton into length is 1200 mm. So now this will be divided by area is 500 mm square, 500 mm square into we have here Young's modulus 80 kilonewton per mm square, 80 kilonewton per mm square. So now after simplifying this whole equation, that is this one, after simplifying this whole term, we will get here answer delta L is equal to 0.85 mm. Okay, this is our total elongation of the brass bar. Okay, So students, in this video we have understood about problem based on principle of superposition. Thank you students for watching this video. Like, share and comment for this video and subscribe my channel. Thank you.